I must be getting old. Hello there, kitties. I'm Kerry, the vacuum tube witch. It's been a long time. Long time no videos. So much stuff has happened here. And I had to take my time fixing my filming setup, but looks like it's all set now. And looks like it's time to modify one of my projects, the ThermoNIX, because I came up with an idea to add a calibration circuit to this thing when I was away with my mom. So here's the schematic of what I'm gonna do. Let's move over to the bench and I will explain what this is all about. So here we are at the bench. Let's zoom on in. Yeah, this should be fine. The ThermoNIX mod with an external recorder output and calibration potentiometer. I've got some parts somewhere here. I'm gonna be adding those. A BNC socket and a potentiometer. And a pair of diodes and resistors. And I'm gonna add a circuit here. Not gonna use the rotary switch for sensor select, but the 0 button that I'm gonna repurpose to calibration button, but for the source of the calibration voltage, I'm gonna use a voltage divider with clamp diodes for the something like 600 millivolts positive and negative. Let me see if I have some suitable diodes like 31, 38. Those pesky little buggers, they come in handy everywhere. And I'm gonna use those in this project. If necessary, I will add an operational amplifier buffer, but I don't think it's gonna be necessary now. Time will tell. Sooner or later, time will tell. And since those diodes have something like 600 millivolts voltage drop, let's see how much exactly they have. .602, that's one of them, and the other one 0.607, good enough for Australia. That would mean that I can calibrate the meter in the plus minus 600 millivolt voltage range, and since the LM35 temperature sensor outputs 10 millivolts per 1 degree Celsius or Kelvin, that effectively allows me to calibrate it from minus 60 to plus 60 degrees Celsius. And this will come in handy when setting up the recorder I haven't shown the recorder I have here, but we will see it in action. So that's for the theory. And let's get on to the practice. I almost forgot how to discombobulate this meter, but yeah. Let's not get too carried away. So this looks just like I showed you in the ThermoNIX video. And now we're gonna add a little modification to this circuit. First modification will be the BNC output socket. I think the best place for it is here, but I will have to make the hole a little bit larger to accommodate this. So how much exactly do I need? 9.5 for 10 millimeters. So, you know, the drill. My favorite step drill. Of course, there's some burrs on the inner surface using the deburring tool. It looks nice enough. And now time to attach the BNC connector. And my Fran Lab inspired wrench. I think I will need to hold the socket on the other side. Yeah, that's good enough for Australia. And if something is good enough for Australia, then it will be good enough for Poland as well. So there we have the external socket. And now we've got this switch with the ground connector on its side. It's time to get to this switch, and I think I will have to discombobulate the other side of the enclosure. All that matters now is to take off the ground contact from this pin. And use it for the calibration potentiometer. I'm gonna add somewhere here. I can do it now. Yeah, it goes into the hole just like this. I'll use this toothed washer on the inside surface. Do I need a 10 or 11? Yeah, I need an 11 with this FranLab inspired modified wrench. I will leave this potentiometer as it is with screwdriver operation. There we have it. I will also need to get the plus-minus DC voltage from this board. I think I can place the resistors on it while I'm working at it. So this is gonna be a little bit fun. Let's do it from another angle. So I have to be careful not to damage the cables. So yeah, one of those contacts is already liberated from the cable. I think it's best to use a solder socket now and make a clean connection. one more cable sticking. And remove the big solder blob. This is gonna be something like a star ground point. And one more wire. So now I've got this contact freed up for the calibration part. And I should look for a 3-wire cable in my lab. So I've got it. Oh, maybe I should use a 4-wire cable instead. One of those wires will be positive, and the other will be negative. The third one will be the wire from the potentiometer, and the fourth one will be the wire to the BNC output. Yeah, that should be good enough. Ain't this a clever invention? So now we've got this cable bundle. I will change the zip ties later. But we need to go to the switch and the power. So yeah, the yellow wire on the switch, it will have to go out to the BNC output, and the green wire from the potentiometer will have to go to the bottom contact. Yeah, that should be enough wire. So brown and white go to the power board. Green and black go to the switch. Black goes together with yellow. And green goes to the contact we just freed. There goes the switch. And now the board. Gotta unscrew it to work on it. I will need two 1.5K resistors and the diodes. Yeah, the left one is 78, this is the positive, the right one is 79, and this is the negative. So we've got incoming power right here. And I can install those resistors on the sides. On the sides and going back. And then I will just install the diodes right here. There's a little bit of work on the negative side, but it can be done. And now for the diodes. The middle contact will go to the ground. And fortunately the ground is right here. So we're good. And now it's time to connect the two wires going to the potentiometer. So the positive goes here. And the negative goes over there. And there we have it. All done on the board. Time to reattach it to the enclosure. And now it should work. But let's see if it works at all. So if I plug the ThermoNIX into a socket, turn it on, it doesn't have a sensor connected right now. If I connect a sensor to the... yeah, it should be showing the temperature outside. But if I press the calibration button, it will change the value shown. Maybe the range, change the range. Now I'm turning the pot. It's even plus minus 70, not plus minus 60. Yeah, let's get it as close to the real deal 0 as possible. I think I should have used a multi-turn potentiometer. I think it's good enough. And now let's measure the voltage. Two millivolts DC. If I switch this off, and change the range, 4.6 degrees. Measuring the voltage on the output shows 46.2 millivolts. So we've got the signal output and the calibration is gonna come in handy for calibrating the external recorder. And now, since the work on the ThermoNIX itself is done, I can put it back together. There we have it. But I've got something else on the bench. Apart from that ThermoNIX, so it has those connections at the back. A nice unit made by Kip and Zonen in Delft, in the Netherlands. Also has a Lemo connector for something external, but I'm not sure what exactly it is for. BNC goes to BNC. Now I need to find a AC power cord. Powered up, I can move the pen to zero it. Change the range. But what is a recorder without a pen? It's going highly negative because the sensor is disconnected. So I've got the recorder all set up. It's sitting on top of the ThermoNIX. The ThermoNIX is at the calibration setting. If I turn it off, then the calibration and go into the measurement mode, the pen on the plotter would have moved. Now I wonder if I can find a real pen to put into the plotter. Might need some adjustments. Hacking something out of nothing. Oh, I can take this out and work on it while not on the recorder. Looks like we're good to go. And it it looks like it's recording. Let's raise to the proper temperature. It is doing science. Back to close to 0. Let's move the camera just a little bit. So now I've got a working setup for recording the changes in temperature for any process or outside temperature. Doing it the real deal old school analog way. Maybe let's make it move somewhat slower, like 1 millimeter per minute. That will use 60 millimeters of the paper per hour. That would mean that I can get a whole day of measurements of temperature within something like 1.2 meters of paper. For science. So that would be my little comeback to YouTube with a meaningful project for measuring and registering the temperature. Hope you liked it. And I think that I will carry on making videos and streaming again this year with my new and improved setup. I will definitely make a video about what I changed in my filming setup, because this is I think this is an interesting thing in itself. I had so many problems to solve when setting this whole thing up. And without further ado, you know what I'm gonna say? Stay determined and carry on. Bye!